random sample of size 40 workers were selected from a group of workers in company A, and 8 of them were found to be performing below expectation. A second sample of 50 workers were selected from a group of workers in company B, and 9 were found to be performing below expectations. Test at 5% level of significance. 5% level of significance. The hypothesis that the proportion of workers performing below expectation in the two companies is not the same. So in this scenario, our N, the total number of workers is 40. So our HO is that the performing worker is not equal to, is the same. Our HO is not opposite performing P1 is equal to performing PA. Then my H1 is equal to that is PA is not equal to PB, which is A and B, which is the first group, and group A, company A, and company B. So in such scenario, to get for our PA, therefore PA would be equal to 8. 8 of them perform below 8 divided by 40. That gives me 0.2. And in B, PB is equal to 9 over 50. That is 0.18. So having done that, then we can go ahead and prepare our test statistics. In our test statistics, which is reaching our Z curve, is equal to, what is the formula as PA minus PB over square root of PQA over the number of A plus the second part, part over the number of P. So that will be equal to 0.2 minus 0.18 as seen above over square root of, so P 0.2 multiplied by 0.8, so that is 0.8, 0.18 over our N is what? That is 40 minus 0.18 multiplied by 0.82 the other way around after deducting them. That gives us over 40. So that will definitely give me, yes, 0.2. So let's write that down. That is equal to 0.02 over the square root. That's the square root of yes. I'll be careful in calculations. Yeah, I got 0.006852. And that's equal to 0.02. The square root of that gives me 0.0834. So that's equal to 0.24. Then our Z tab is equal to Z that was 0.0 significance divided by 2. That's Z 0.05 divided by 2. That's equal to Z 0.025 is equal to plus or minus Z 1.96. Now level significance 0.05. So since Z cal is what, 0.24, is less than 1.96 for Z tab. I have to accept the known hypothesis and conclude that the two proportions are the same. So I'm going ahead with the known hypothesis, which is this. Then now B, manager of a bank claims that 60% of short-term loans granted usually result to failure. A random sample of 200 short-term loans recently granted that was selected. After investigation, it was found that 140 resulted to failure. Test at 5% level of significance whether the sample level evidence contradicts the manager's view. Now B is equal to 60% or that's a 0.6. Then the Q, which is the other part. Yeah, so of course, 60% result to failure, then the other part should result to success is will be 0.4. The was 100. Our level of significance is 0.055%. Then the number of data working with is sample working with is 200. That's 200. The number of failure go there. So n underscore r is equal to 140 is a number of our failure. Therefore, my p is equal to 140 divided by 200. Because after the investigation, it was found that 140 resulted to failure. So now we're going 140 here. Alright, so then that gives me 0.7. Then my known hypothesis is equal to my known hypothesis P is equal to 0.6. And P is now is equal to 0.6. So therefore Z is equal to P minus P over square root of PQ over NR. So that will give me 0.7 minus 0.6 over square root of 0.6 multiplied by 0.4 over 200. So that gives me 0.01 over 0.3464. That's equal to 2.87. So then for Z then for Z I'm using level of significance. That's Z 0.05 divided by 2. That's Z 0.025 is equal to plus or minus 1.96. So since Z tab is greater than Z cap, so that we get the known hypothesis and that there is sufficient evidence to support the manager's claim.